Hello. In this session, we are going to introduce the artificial intelligence and machine learning. And in this, we are going to cover the topics in the syllabus. What is deep learning? As a part of that, what is the artificial intelligence? What is the machine learning? In the next session, we will go into the deep learning concepts. Now, as we discussed in the last session, the artificial intelligence is having so many subfields. One of the major subfield is the machine learning, and another subfield for the machine learning is called the deep learning. So now we are going to discuss about the artificial intelligence. Actually, the artificial intelligence was born in 1950s, not the recent technology, and it was started from the thinking of about whether the machine can think or not. So the people started asking whether the machine can think or not, and still now also we are exploring that. And artificial intelligence finally crystallized and it was finally announced as the area of research in 1956. And John McCarthy is the assistant professor of mathematics at Dartmouth College. He organized a workshop, summer workshop, and so many members have attended for this workshop. Of course, the workshop outcome was not that much satisfactory as expected, but it was the starting step for thinking and to motivate most of the people who are interested in this particular field how to think with the machine. The machine can think or not. Most of the people are motivated because of this workshop only. And he is the John McCarthy. In 1955, he developed the first, that is the artificial intelligence, and 1959 he wrote the programs with the common sense. In 1960, he started with the Lisp implementation. The first Lisp implementation. Lisp is the programming language which is designed for the artificial intelligence, and from the in the last 10 years back also it was the major subject in the computer science. So because of the advanced technology and advanced programming languages, we are not seeing this programming language in the current era, but it was the first programming language for the artificial intelligence. In 1971 he got the Turing Award. It was the prestigious award in the computer science. So he got that in 1971. And the artificial intelligence, it describes the effort to automate the intellectual tasks as the humans. So meaning that we will make the machines to think like the human, so that we have to automate that. The artificial intelligence will deal with those type of algorithms. And AI is the general field, and it was having so many subfields, and the most major concepts of the artificial intelligence are the machine learning and the deep learning, and of course so many other approaches are also there. One of the major approach is the symbolic AI, meaning that in this the programmer has to write the rules explicitly, and it will manipulate and it will store the rules, and those rules will be handled and those rules will be applied on the given input, and it will take the decision. That is called the symbolic AI. So the list was designed for that, and it was the dominant paradigm of the AI from the 1950s to 1980s. It has the dominant performance. And symbolic AI, it was suitable for the classic well-defined solutions, like the logical problems like playing chess, and fuzzy problems like image classification, speech recognition, or the natural language translation. All these are comes under this symbolic AI. So image classification comes under if you give one image that can be identified what kind of image it is. It may be the tomato, or it may be the banana, or it may be the beetroot. What is that? We can recognize. There is the classification. It comes under this classification. Or the image is comes under the chest X-ray of the image, that comes under the pneumonia infected or not. That can be also comes under the image classification. Speech recognition, meaning that if you give some speech, that can be converted into the translated into the text, and that can be displayed on the screen. That is speech recognition. And also the natural language translation, one language to another language translation, is comes under this category. And now let us enter into the subfield of the AI, that is the machine learning. So the machine learning is the symbolic AI's next level, meaning that symbolic AI is handling the classical problems, and the machine learning, it can handle more intellectual. So where it was started, that is, of course, you can recognize these persons like Dennis. He is the Charles Babbage. He is the father of computers, and Ada Lovelace. She is the first programmer. She is the first programmer. And in 1843, Ada Lovelace remarked in the innovation of the analytical engine. She was the first programmer, software designer, and even in the 178 years, of course, more than that, we are still following those rules only. And she was remarked in the Alan Turing's paper, that is the computing machinery and intelligence, in 1950s. He mentioned the Ada Lovelace services and in the computing machinery and intelligence paper. And he introduced the Turing test as well as the key concepts for the artificial intelligence. He is the Alan Turing, and he is the beginning of the artificial intelligence. He is the beginner for the artificial intelligence. And now the machine learning, if you understand the concept, there is this difference between the classical programming and the machine learning program. The classical program, we have to give the set of rules and the data, so that based on the set of rules, the given data will be analyzed and you will get the answers. That is like the classical problems. Let me and the machine learning, it will accept the data and answers. You will give the data and answers to the machine learning algorithm, and it will identify the rules. It will build the rules. Like in the classical programming, a simple example is tomato is in red color. A simple rule. We are giving the rule, meaning that if you give the data as the tomato, what is the color of the tomato? It will give you the red color. Meaning that the set of rules will be stored and it will be identified. If you give the tomato, then it will give you the color as the red. But here you will give the data and answers. What is the data? The input may be the tomato picture or description about the tomato, and the answer you may give the answer, or you may give the prompt like red color, meaning that if there is the tomato, there will be the red color. That is, the rule will be formed by the machine learning algorithm. So the machine learning, it is little different from the traditional programming. The machine looks at the input data and the corresponding answers and figures out what are the rules could be, what the rules. And for the next input, it will identify what is the answer. So the machine learning, it has to get trained. It is not explicitly programmed. We will not program the machine learning. We will train the machine learning algorithm. So that is the machine learning. Now, the machine learning, actually, it was very popular in 1990s, and it was developed a lot with so many algorithms in 1990s as the subfield of AI. And the trend driven by the availability of the faster hardware and the larger data set. Actually, previously we didn't have the proper data sets and the computing power. Because of the development in the hardware and also the data sets collected, the data set, it has become popular in the AI. Why? Because in the olden days, there was no digital data available. Slowly, they started digitization of the data so that the large data sets are available, and also the computing power was also improved based on the parallel programming and the parallel computing, and also the advanced processors. Based on all of them, the hardware was improved and the large data sets are also available, so that the machine learning was had the importance of it had the availability to improve. And the machine learning, it is related to the mathematical statistics, but it is different from the statistical in various important ways. And the statisticals, in the statistics, it cannot handle the large data or complex data sets, but the machine learning can do that. And the statistics are mathematics or physics, they are the theory based, but it is the hands on. So classical statistical analysis such as the Bayesian analysis, it may not be the practical, it may be the impractical. And machine learning, especially the deep learning, it exhibits a comprehensively little mathematical theory, and we can call it as the engineering field, engineering discipline. We can call it as the engineering discipline. It is not like the mathematics, statistics and physics. They are completely theory based, but the machine learning, it is the practical based, so that it can considered as the engineering discipline. And unlike the theoretical concepts like physics, mathematics, and mathematics and statistics, the machine learning, it is the hands-on field, and it was having the so many concepts, and we have the so many advances in the software and hardware, and those developments can be incorporated in the machine learning techniques. So these are the topics I wanted to discuss in this session. Thank you.